Let's go ahead and take what we know about transformations, or what we've discussed about transformations of exponentials so far, and talk about how to approach combinations of transformations. Now, this will largely be the same as how we approached combinations of transformations when we discussed transformations in general. And that is, first we'll make sure that any vertical shift is not multiplied, so the vertical shift here would be due to the +4, is not multiplied by the vertical stretch, compression, or reflection. So in this case, it's not. The -2 is not multiplying that. And we'll also make sure that any horizontal stretch, reflection, or compression is multiplying the horizontal shift. And here there's no horizontal stretch, reflection, or compression, so that would be true. Once you ensure those two things happen, you can simply list the transformations, putting the shift last. Now, it may help you as an individual or as sort of an intermediate step to write out what the parent function is. When you have exponential functions, the parent function is just going to be whatever the base is to the x power. So in this case, it's 3 to the x. And if you rewrite this in terms of f of x, you can clearly see what number here, or what part here, goes with which transformation. So this is going to be equal to -2 times f of x minus 1 plus 4. So this allows me to see that I have a vertical reflection, a vertical stretch by a factor of 2, a vertical shift up by 4, and a horizontal shift right by 1. And as long as I write out the order of the transformations so that the shift is last, then the order will be correct. So this is, let's say, vertical reflection. And since it's vertical, it has to be about the x-axis. We have a vertical stretch by 2. We have a vertical shift up by 4. And then we have a horizontal shift right by 1. And so we could graph this by graphing 3 to the x and applying these transformations in order. Then from the graph, we could determine things such as the horizontal asymptote, the domain, the range, and other properties that perhaps you're interested in from the graph of the function. So remember, follow the guidelines from combinations of functions from the transformation of functions section, and this will largely be an application of that conversation.